So first thing we need to remember, because we're going to be just doing linear equations in the piecewise function today. So the first thing to remember, y equals mx plus b form, or in some cases, some may refer to that as ax plus b form. And what we want to remember about that is whatever is with the x, that is our slope. That tells us rise over run. Basically what that means is how much we go up or down, depending on if it's positive or negative, and how much we go right. Other ways to look at that, of course, but that's the one that kind of sticks with people. The b value, that is our y-intercept. Got a little messy there. So if we're looking at a coordinate plane, the y-intercept, needs a t, is where our line is going to cross the y-axis. And that's generally where you start most equations. Like if I have y equals 2x minus 3, I'm going to start down here at negative 3, and I'm going to go up 2 and over 1, up 2, over 1, up 2, over 1. I'm going to make my line. So remembering that is important. If m equals 1, there's usually just an x. So like if I have y equals x plus 2, that means my slope is 1, and my y-intercept is 2. If I have something like y equals 2x, there's an implication that that's plus 0. So that means I have a slope of 2 and a y-intercept of 0. So, and you may see any kind of addition to that. Also, if I have something like y equals 4, that means I have a 0 slope and a y-intercept of 4. So that is my y-intercept. And what that looks like with 0 slope is if I start, and change colors here, if I start at 4, I'm not going up or down, I'm just going over. So this is anytime we have y equals a number, this is just a flat horizontal line at that number. Which brings us to piecewise functions. Now, piecewise functions don't have to have just lines. For the sake of simplicity, for the proficiency level, we're just going to do lines on ours just to keep it easy to handle. Okay, so the first thing you're going to do, and this, again, this is one way to do it, not the only way to do it. This is just the way that I've found works for kids who have tended to struggle with this particular skill. First thing to do is draw vertical lines at what are called your breakpoints. So the first thing I want to look at here, this is my domain. These are my domain restrictions or my domain guidelines. What that means is that this equation, f of x or y equals negative 2x plus 1, is only going to exist where x is less than 1. And then my y equals negative 4 is only going to exist between 1 and 4. And then negative x plus 3 is only going to exist beyond 4. So one of the things that helps people is to figure out what those breakpoints are. So if I'm looking at my numbers simply in my domain, over here, 1 is one of my breakpoints. So I'm going to draw a vertical line at x equals 1. And then my other breakpoint, these both have 4 in them, and I'm going to draw a vertical line at 4. Now, once I do this, I don't need to use these again in graphing my lines. I'm going to use them to figure out endings and beginnings, but that means that one equation is only going to live over here, one is only going to live here, and one's only going to live here. I'm not going to have any one equation move into the other one. So I'm going to do this one in red, I'll do this one in blue, we'll do that one in green. So the first thing I want to look at, and I need to be in red for this, is negative 2x plus 1. So that has a y-intercept of 1 and a slope of -2, or m equals -2. So I'm going to start at 1, and my slope is -2, so that means I'm going to go down 2 and over 1. I'm going to erase that real quick. So what I would do normally, sorry, trying to pick up that ruler. Oh. Nope, I'm going to pause and see if I can separate that ruler. Okay, ruler separated. All right, I'm going to take my ruler and I'm going to put it at 1. And then I'm going to, oh, come on, stop grouping that. Okay, I'm going to try that again. Okay, this may be a work in progress because I've got, it's just, yeah. My technology is not being my friend right now. All right, so what I want to do, back to this, take my ruler, and I want to line up my ruler at 1, where y equals 1. But I want to turn it so that it goes down 2 and over 1, and line it up so that it kind of does that all the way across my graph. And this is tricky because this isn't an actual ruler and it's not working that well. So what I have here, and we'll see how this part works, red. So y-intercept of 1 and a slope of -2. So this also goes all the way back. Also not a regular ruler, so drawing that line is tricky. And that is where that line exists. Oh good, it let me separate the ruler. Next thing I'm going to do is go to y equals -4. That one is, significantly easier because y equals -4 down here. So I just have a flat line going across. And it only exists, it only exists between 1 and 4. So it's only in this middle section here. So all I'm going to do is in blue, go from one boundary to the next. That's all I'm doing with that one. And then my last one, -x plus 3 is going to have a y-intercept of 3 and a negative slope of 1. So -1 over 1, -1 over 1, -1 over 1. So down, or I should say down 1 and over 1. And I'm going to continue to go down 1 and over 1. And I can do it that way too. I don't have to use the ruler if I don't want to. And I'm not going to start it until I get here, because all I want this one is for x is greater than 4, which is over here. So one way to do that, take my ruler, line it up to go down 1 over 1 from 3. This is much harder with a virtual ruler than it is with a real ruler. I think I got it lined up there. So normally, while this line would go straight across here, I'm going to undo that, and all I really want it to do is start at the boundary and go down. And then I can get rid of this ruler because it's not being terribly helpful for me. So this is my piecewise function. The yellow lines are not actually part of it. They're just helpful for knowing where to start and stop your equations. The next thing I need to look at, and I can look at this before or after, I don't have to do it in the order that I'm talking about, but this first one, -x plus 1, is if x is less than 1. So what that means is I'm going to have an open circle at 1 where that line stops. The next part, -4, y equals -4, goes between 1 and 4. So x is greater than or equal to 1. So that or equal to tells me that I'm going to have a filled in dot at 1 and an open dot, because it's less than 4, at 4. And then the final one, because this is greater than, x is greater than or equal to 4, I'm going to have that filled in circle. And that is my piecewise function. As I said before, those yellow lines are not a part of it. But they do help you to figure out, especially if you're using the ruler method, where to stop and start. So that's kind of the basics of piecewise functions. I'm going to talk real quickly about step functions, but they're just another type of piecewise function. Oh, a couple things to note. Forgot that. In any of these sections, only one thing should live. So I'm at -4 right here. That means if this line, the green line, were to overlap in here and I had two lines happening in that same section, I would have done something wrong. Then it's not a piecewise function because it has two things overlapping vertically. So keep that part in mind. Okay, so now on to step functions.